So you're familiar with the quadratic formula, but have you ever wondered where the quadratic formula came from? Now that we know how to complete the square, we can actually derive the quadratic formula. And by the way, no, you do not need to know this for the test, but good for everyone to see where it comes from. So we're going to start with the quadratic equation in quadratic form, and we're going to complete the square. So first I'm going to go through, divide everything by a. That way I'll have a leading coefficient of 1. Zero, of course, divided by a is still 0. Then we're going to kick the constant over to the other side and find our magic number. So bringing this over will be a negative c over a. And then our magic number will be half of b over a squared. So b over 2a squared plus b over 2a squared. Now the left side of our equation should factor to a perfect square. I'll go ahead and put in the factoring step. So this is going to factor to b over 2a and x plus b over 2a. Over on the left side of the equation, we can tidy things up a little bit. We can square here and get b squared. Squaring the 2 and squaring the a will give us a 4a squared. So this side is now a perfect square. And over on this side, we can get a common denominator. So we can take our c in here, and we can multiply this by 4a over 4a. That way I'll get a 4a squared in the denominator. Get my pen back here. And this will become a negative 4ac over 4a squared plus b squared over 4a squared. Once I have the common denominator, I can add the numerator. And that c doesn't look much like a c. Let's clean that up a little bit. Okay, then we have x plus b over 2a squared equals, I'm going to swap the order here and make that b squared subtract 4ac all over 4a squared. Now I'm going to square root both sides. And so that will give me x plus b over 2a. So that eliminates the square. Over on this side I'll have the plus or minus. And I'm going to split it up. The square root of b squared subtract 4ac over the square root of 4a squared. I think you might be able to see where we're heading with this. So tidying up a little bit. Plus or minus. So I'm going to have the square root of b squared subtract 4ac. There's our discriminant. Square rooting the 4 and square rooting the a squared will give us 2a. Now I can subtract the b over 2a to the other side of the equation. Let me come up here so I get a little more room. So I'll have x equals negative b over 2a plus or minus the square root of b squared subtract 4ac all over 2a. And since I have a common denominator, I can go ahead and combine those. And there's our old friend, the quadratic formula. So that's where it comes from, completing the square. Using this, hoping you don't have too much trouble with this and that it's review material. So we do have to be in standard form when we use the quadratic formula, ax squared plus bx plus c equals 0, which this one is. So our a value is 2, our b value is a negative 6, and our c value is a negative 1. So watch the signs there. Substituting in, x will be equal to negative b. Since b itself is a negative 6, the negative of a negative 6, or the opposite of b, is going to be a positive 6. Plus or minus the square root. That negative 6 squared will be 36. Subtract 4 times 2 times negative 1 by 4 times a times c all over 2 times a. So I've got a little bit of arithmetic to do to tidy things up here. So I'll have a 36 here, and let's see, 2 negatives, this will turn into an addition, so that's an 8, and 2 times 2 is a 4. And hard to tell ahead of time just how much work some of these will be to clean up the square roots. This is going to be a 44, a 36 plus 8, all over 4. And this will clean up a little bit. We kind of go over here on the side. The square root of 44 is 4 times 11. So the square root of 4 times the square root of 11 becomes 2 times the square root of 11. So part of it cleans up, part of it doesn't. And what I like to do is actually split this into 2 fractions to clean up my fractions. And then I get 3 halves. The 6/4 reduces down to 3 halves. The 2/4 reduces down to a 2 in the denominator. Square root 11 over 2. So this is the shorthand notation. You also could write the solution as 3 halves plus the square root of 11 over 2, and 3 halves subtract the square root of 11 over 2. If we wanted to find the decimal approximation of our solution, working in this notation, typing this into our calculator, then typing this into our calculator will be the easiest way to get the decimal approximation. Okay, so I've got another one over here. I'll go ahead and pause for a minute, and you hit the pause also. Give this one a try, and we'll see if we get the same result. So how did that go? Want to again start off with identifying our A values. And now that I'm taking a second look at my work, I can see I actually made a kind of a silly error. My variable in this problem was actually a y rather than an x. So I'm solving for y here. Using the formula, negative b plus or minus the square root b squared subtract 4 times a times c. And then we can do the arithmetic. So I ended up with my discriminant simplifying to a negative 24. So with the square root of a negative, I know I've got a complex number, so I've got my I. I cleaned up the square root of 24 and found that it was equivalent to 2 times the square root of 6. Simplifying, again, I split it into 2 fractions, putting both the negative b over the 2a and my square root of my discriminant over the 2a. The negative 6 over 6 give me negative 1. The 2 and the 6 reduce down to 1/3. Actually, here's a good thing to talk about. The 6 here cannot reduce with the 6 here because this 6 is inside the square root. We can only reduce if it's actually a factor. So we've got a plain 2 over 6. That reduces down to 1/3. And then I need my I for my final result. Speaking of the discriminant, it's kind of a little test you can use. Sometimes you're in a situation where you're only interested in the solution to an equation if it's actually a real number. So one way to check whether or not if a quadratic is going to have a real solution is to go ahead and just look at the discriminant first. And what we know is that when we're working with the discriminant, if it calculates out to be a positive value, there's going to be 2 real solutions to the quadratic equation. Because in the quadratic equation, we're taking plus or minus the square root of the discriminant. If we're taking plus or minus the square root of a positive number, the square root of a positive number is real, and we'll get the 2 solutions. If the discriminant turns out to be 0, we're going to have negative b plus or minus the square root of 0 over 2a, and we're only going to have one solution, just the negative b over 2a. And if the discriminant's negative, we're going to have negative b plus or minus the square root of something that's negative. The square root of a negative is what leads us into the i's. And so we're going to have 2 non-real solutions. Graphically, if you think of what the graph of a quadratic equation looks like, it's a parabola. This will correlate. If we're going to have a positive discriminant, 2 real solutions, the parabola will intersect the x-axis in 2 places, and there'll be 2 x-intercepts. If the discriminant is 0, there's only going to be one real solution, and that's going to correspond to the graph of a parabola that just touches the x-axis at one spot, so one x-intercept. And if the discriminant's negative, that's going to correspond to the graph of a parabola that never intersects the x-axis, has no x-intercepts. And of course, we can use quadratic equations to solve word problems. The classic example are the following object problems. So if we have an object thrown upward with an initial velocity of 15 feet per second from a height of 100 feet, the height of the object after t seconds is given by this formula. Where the extra pieces went in, the initial height of 100 feet is going to be the c value. The initial velocity of 15 feet per second will be our b value. And the a value, the negative 16, has to do with gravity. And this particular problem, we're looking for how long will it take the object to hit the ground. So if we're throwing the object from a height of 100 feet, it goes up, it hits the ground. The height of the object when it hits the ground is 0. So we're going to take this equation and set it equal to 0. And we're looking for how long it will take the object to hit the ground, so we're trying to solve for t, because that's our time in seconds. So solve this with the quadratic. Negative b plus or minus the square root. B squared, subtract 4 times a times c, all over 2 times a. So running the arithmetic through my calculator, I discriminate 6625 over 2 times negative 16 gave me the negative 32. The square root of 6625, it's not a particularly nice number. It's irrational. But if I'm trying to answer the question, how long will it take the object to hit the ground, this is going to be a useful number, even though it's not good, even though it's going to be an approximation of the time, because having a square root in my answer is not going to be useful when someone wants to know when is the object going to hit the ground. Running that through my calculator, I came up with 2 solutions, one of which is a negative 2.07. Now I'm trying to find the time. Time cannot be negative unless we've got a time machine. So the only solution that makes sense to the particular problem is the positive solution. So it will take about 3 seconds to hit the ground.